Hello, everyone. Welcome to day three of this week, where we're going to be having two new workshops for all of you. GM, feel free to say hi in chat section. Just at GM as well. Let me know where you're all coming from. We have two very interesting workshops today from the Internet Computer team. Two of them starting 30 minutes apart. First one being the Inference On-Chain by the Side AI, and then using a vector DB on ICP. Anonymous, I think that yes, I think there might be an issue with the settings for the event, which is why some of you show up as anonymous, or you may not have filled in your name when you were joining. I can see that Kapil here has filled it in, so maybe that's the issue, but I don't think it would impact the event. I see Jeshli here, who's going to be our very first speaker. Let me just quickly invite him on stage. And as I said, we will have two speakers today. In the meantime, I just wanted to take the time and tell you all about, I don't know if all of you have managed to see, hey Jeshli, if you've managed to see the announcement today, we will be expecting that all of you submit an idea of like towards the end of next week. So we would love to know what you all will be planning to work on during this hackathon, and we will then try and support you accordingly. So let me just quickly show you a quick link. You will be seeing it towards the bottom left side of your screens. This is going to be the form you can that you will be using to submit your idea. Ideally, you can get acquainted with it, see what you will have to submit. It's quite basic, and it needs nothing more than 2 minutes of your time to fill in. But again, no need to fill it in right now. The deadline for submitting it is end of next week. So feel free to enjoy all the workshops that we've planned. Make a plan, discuss with your team, and towards the end of next week, make sure to fill it out, and we'll then provide ample support and connect you with the teams that you will be building for, hopefully to get the support that you might need. Without further ado, Jeshli, how are you doing?
Pretty well. Thanks for asking.
Fantastic. Floor is yours. Everyone, okay. If you would like to share any questions, make sure to use the chat section towards the bottom right side of your screens, or post them in the questions tab as well. Over to you, Jeff.
Okay, thanks. So today I was going to go over a Git repository with an example of how to deploy ChatGPT-2 onto the back end. I published an article back in early March about the current limits of how many tokens we could process. That's called the Internet Computers AI Frontier, published under modclub.ai. And that speaks to how many tokens we could process and how quickly. And the two main aspects to think about when you're doing that is the query or update methods for interacting with the canister. So we have something alive on chain, which is essentially the GPT-2 tokenization followed by convolutional neural nets for efficiency to detect abusive text. So this is live on the Internet Computer. And so the idea that was important here, although it seems to be a bit slow, is that speed was the priority. So this is under what I would call so if I go to the Rust Connect Pi AI to IC, a single query demo. So it's essentially just a bit of an add to the single query demo. And the idea is that you just have your single model efficient enough to run as a single query. So that means less than 5 billion instructions. So decoder blocks for a GPT-2 size using the tracked Onyx formatting could only handle about 12 tokens. And then using an update, which is around 20 billion, it could handle 52 tokens at a time. And then there's upcoming DFX release. There's an upcoming DFX release, which will make it about 4 times more efficient because they handled floating points more efficiently deterministically. And what I'm currently working on now is quantized models with SIMD. So they are also in beta for SIMD execution within Canister. So that's my priority for getting models on scale. But then there's some other aspects about, like, so if you want to run larger models, you would need to separate it into chunks. So what we have in the Python script section is all this is doing is taking the GPT-2 model, which is 12 decoder blocks and an embedding block, and it's creating an embedding block, an embedding model, and then 12 decoder block models, and then it's saving it to the Onyx format, which is what I loaded it into the Internet Computer as using the track library. So if we go forward to just accepting that you know, people would know how to create a model in PyTorch or execute this. Essentially, you just need to install Torch and the transformers library from Hugging Face. And then you would be able to run this script, which is provided, that produces the GPT-2 sectioned out models. And then we can go forward on the Internet Computer sub-examples. So we have the single query example. And so we will want to, when you run it the first time, cargo build the backend before deploying, so that it can download the required libraries locally. And then these are the regular DFX deploy notes. So I'm not working from my regular computer, but I have tested this before. So I'll start DFX in the background. This is only version 19, but it's pretty recent. And then what I need to do is open up the canister. So it's the backend canister. These are the functions that are built into it. Most of them are just for processing the model. The only one that's like actually running the model is the model inference function. But what we have here, then if we go back to the README, so all these commands are here. If we run the Python script, which is in the main README, the walkthrough for that, then we can call the cargo, the Rust canister script that that is written for loading. I'm getting no matches found. I don't know why. Because the Mac is different and it doesn't acknowledge the brackets. So it has to break them up into 2 megabyte chunks. So one thing I also would note about the transformer efficiency is that the 79 2 megabit chunks are for the embedding model, just the embedding section, and that's actually much larger than, say, the transformer sections of the model, but it's essentially a lookup of a vector, so it's far more efficient when it comes to instruction limits on running a query or update. So it's pretty efficient in terms of what we are concerned about for the current limits. And so after that uploads, we call 2 functions. We call the model bytes the plan, and then plan to run a model, and then we can run inference in this example. We can just input it, but I'll wait, and then I'll skip ahead a bit. So while that's running, to go review that we also have the multi-query single canister demo. And this would be the same setup, except you can now upload a sequence of models, and it will automatically call some of the other stuff. So we have to initialize the pipeline of models, and then after every model that uploads, it calls these model bytes to plan and plan to running model. But the other thing to note is that I have, at least on one or two occasions when uploading the model to the internet computer, had interrupt during upload. So I also included WASM ref cell length to tell me how many bytes have been uploaded. So I can call that, and then if we review the upload function, if we review the upload function, am I on the multi-canister? So the multi-canister doesn't have an index, so you'd have to go single file if you get interrupted, just for the file that you get interrupted on. But then you simply call this function. I can go back to the single query demo. So when we upload it, we set it at 0 because we're starting at index 0, but you simply just replace it with whatever value is returned here. So I should be able to upload, not worry about interrupting it. So I could just copy and paste this and set it to 0. And then I would be good to go on having a model resumed being uploaded. So other than that, the main thing I wanted to talk about, which isn't explicitly in the demo, is what I mentioned earlier, which is the update versus query. So we can see here, we have the model inference set as a query. You would just remove query here, and in the actual lib.rs, you would go to the model inference and change this to an update. So change query to update. So we see that the model is fully uploaded. We can go to our canister. We can check this, and we can check that matches the original statement. Yep. And then we can give it some, so this is a vector of int64s of 4, 5, and 686. So that is an uploaded embedding. And if we wanted to, which I'm happy to do, we could upload the multi-canister approach and demonstrate what the limits are, sort of in the process. But the code set up so that using, like, anyone that's familiar with Torch, you should be able to make a model in Torch, and then export it to Onyx using the example provided. There's some functions which don't export to Onyx in a friendly manner, but you can usually just build them yourself if like the important ones are there. And I will start. I guess I'll look at what the questions are, or start talking, trying to answer questions while I go over the multi-query, because I feel like I gave sufficient walk through, and it's all just in the Git repo, and it's all been tested to be working fine. So I don't want to waste too much time just sitting watching files upload. So I'll just try to get that going, and then it seems to have that worked perfectly. Perhaps my Unix versus Linux abilities. All right, so I'm going to stop sharing. If he is the board, imagine what we are feeling. I'm actually not bored, but I am more interested in pushing the cutting edge of SIMD, SIMD quantized models on chain, and I hope that this helps. How many tokens per minute currently? So I was mostly focused on how many tokens could I process, and I was in this research article, which is about to be, put out of speed. It took me to process 52 tokens. It took me 90 seconds, but that was using decoder blocks. So I tried to focus on not including transformers until I can get quantized with SIMD on chain, so that I can process multiple thousands of tokens in sub-second timeframes for my task. So it's just, if you critically need a transformer, you're gonna want to be working only locally. They have the new DFX in beta that has SIMD, and so that's what I'm working on too. And I wanted to get this for you guys today, but I just swamped.
That's good. Any additional questions, everyone?
Wondering why using GPT-2. I like the tokenization, but I really just needed to try around with a small model. Llama C would be the other one, right? Because the tiny stories comes in like even smaller, like 15 million to 117 million, which is around the size of GPT-2, which is by default the small one, which is in like the 100 million. The other things I'd like to shout out too are like Ulan. I mean, like there's the official image classification example, which also uses the track library, which is a really excellent resource because he compiled to WASI and then used the WASI 2IC, which is something I want to compare the two designs and potentially just follow the official Dfinity example for using track, but then also Panda AI. I'll just finish. Panda IC did a candle example, and they only did it locally, but candle is one of the, it has all the Hugging Face features that we would desire, so it might be a really good way to go. What would you consider instead a model that learned on data? For example, So there's examples in the Candle library of learning. I think they only did learning MNIST. Learned on more data. So I don't really know. So like I trained on a subset of data for the application that we showed, like this Rainbow Redactor or the Redactor app. And so you need to train on your thing, but you can use quantized models out of the box in general. But quantization is key, and I'm learning on-chain is something of interest. What is IC expecting the project to do for their bounty in your words? I would think that it's a blend of blockchain valued AI applications. And so I originally just originally did like this redacting application because it was something that was tangible, that was like there's moderation for platforms being done on the IC. So it's like, how about that? But there's a lot of work about on-chain data, like you would find using like Nansen AI is what it comes to mind, but I'm like blanking on where like the block explorer data that we use. That's like mostly SQL, but essentially like anything you could naturally integrate, like if you could query live blockchain data or trigger blockchain critical safety precautions. So another app idea that I put out on the Git repo is about reviewing DAO, reviewing DAO votes to try to determine if you can provide an LLM to diagnose whether this is essentially like a treasury grab or some other like malicious action. The idea being, if you could show that you have an LLM on chain that is able to detect DAO votes that are not in the interest of the community, you could potentially give voting weight to that and have an AI on chain. I would think ideas like that are leveraging the idea of security. Why would you need the AI to be secure? And then security, typically in blockchain, we're focused on money and stuff like that. But I would just think any cool application that you would want is worthwhile.
In the meantime, I've just linked the hacker pack. So those of you that are still looking into what the bounties are or are not don't really know them by heart, you can always have a look at the hacker pack. I've shared the link for convenience, but it has been emailed to each and every one of you upon registration, and we keep on sharing it in the announcement channels on our Discord. So if you have any follow-up questions, do make sure to join our Discord. Make sure to post in the Internet Computer Zone, where we will follow up and link like forward your questions to people that can help you with technical support. Any other questions? I think all good for now. Oh, I can see Alex typing. Maybe something else coming in.
I'm not really sure. What is the best way to follow the questions?
Yes, so exactly as I said. So if you post in the ICP zone on Discord, we will make sure to forward these questions to the ICP team, either directly to Jeshli or somebody else that can help you out with, depending on what is the nature of your question.
Okay.
We can actually see your name, Zaremba, so it's not a problem. Great. Any closing words, Jeshli?
Nothing. Just have fun, and this the IC team, the core developers are rapidly innovating on the AI capabilities that we can do. So I think it's an exciting thing to work on.
Fantastic. Yeah, we definitely want to see a lot of submissions and interest towards these bounties. So again, if anybody has questions, make sure to post them on our Discord, and we'll make sure to connect you with the people that can give you the support needed. Thank you, Jeshli, for this workshop. And now we're going to move on to the second bit, a second workshop for today, which is going to be on using a vector DB on ICP, which is now we're going to invite our second speaker to the stage, which is going to be Wyatt, who will introduce himself and a bit more. Wyatt, you should be seeing a pop-up on your end to join the stage.
Hi, can you see me?
Hey, yes, I can.
Awesome. Thanks for hosting. My name is Wyatt. I'm actually from a team called Kinic. We run something called Kinic AI. You can actually go visit us at ai.kinic.io. We have push-to-deploy tooling for AI on the IC, and one of the most recent ones that we have is actually a vector database that runs completely on blockchain. It's important because if you want tamper-proof data to be fed into your AI or LMs, wherever they might be, it's a good way to have that. So this is important things like healthcare data or other data that you don't want someone to tamper with in the interim. So what we have is actually an example of using our vector DB to have RAG basically serve to BERT and other semantic type models to run. But we'll actually have a video of that later, and I have a presentation kind of showing the specific details. By trade, I am not actually the expert on AI in the team. I'm more of a ZKP, zero knowledge proof type guy, but we'll get into kind of the weeds there, why that would also be useful for AI in general. So Kinic has a vector database running right now on that ai.kinic.io location. I'll share the open source GitHub repo a little bit later. It's good for scalable, verifiable on-chain search with RAG and a few other things you can do. If you don't know what RAG is, it's retrieval augmented generation. It's important for a lot of different things. We need to tweak the data on the fly. For example, if you have internal documents and you already have an LLM, you want it to modify it for those internal documents or things like that. This was originally from a Kinic community demo for the IC community. I'm kind of reusing that for that here. But the same concept, we're going to be showing you a demo of this vector DB running 100% on a blockchain called the Internet Computer. If you haven't noticed, there's a bunch of those logos around here. You run a very large vector database. Right now it's based on hierarchical navigable small worlds. I always mess up. HNSW, and there's a few limitations of that. But we actually have a newer version coming out that's based on Vimana indexing. And with that, you can do actually updating of the index live. Right now, basically, if you upload the data, it's stuck in that state. So every time you have to redeploy a new one. This is where the open source library is at. We're still working on it. It's good for deploying right now as an experiment, but it hasn't been audited or anything like that yet. Currently, there's actually not a GPU subnet on the IC, and there's also not WASM64. So a lot of the LM on the IC that run directly are relatively slow. So in my mind, we have this kind of mixed model where you could potentially have the data store running on a blockchain like the Internet Computer and have the LLM running somewhere else. If it's Candle, you could potentially be using that locally in your browser, or it could be a more traditional, like you own the Web2 server and you trust that server for these kind of mixed type use cases. And if you actually use something called a zero knowledge proof, you could prove the fact that you ran the model correctly. So this like full suite of things, I think, is a very powerful way to have an AI running that's trustless and verifiable. We actually have demos as well of going from Candle to browser and getting it fed from this backend vector database. So we're really into like models that become smaller and smaller over time. Microsoft actually recently released one. I know Candle is a good Rust example, and there's also ones from Google as well. But we expect the models will be more portable, especially since so many people have phones in the world, as time goes on. And with this, the data store is still very important. You might have a lot of data, and that's not really always going to be very portable. Our main goal, Kinic actually started out as a search engine for Web3 data, and we want to use AI to power the next generation of search. So a lot of this is around semantic search and those type of use cases. Also, it's controlled by the Kinic utility token. If you don't know what that is, that's fine. But it is an SNS DAO, Kinic itself is. So it has a token associated with this. And if you use that AI interface that I just showed you, you would actually deploy using Kinic. So a lot of people go straight to the problem, like say, hey, we were going to do a full suite, like the full LM directly on chain. We actually went from like the bit by bit type solution. The first thing is the vector database. We had to build our own from scratch, and it's open source in Rust, and we really needed to support WASM so it works on the IC and also has fast execution, and it's also extremely portable. And RAG itself, should be honest, and tamper-proof. There's a lot of like high-level type use cases that you would not want to just randomly trust like a third-party provider. One would be internal dev docs. Potentially, they could spike it with like false information or something like that. You can imagine any type of like healthcare data, same thing. There's a lot of different types of use cases where you need the vector database itself to be trustless. We haven't done SIMD yet, but we're actually working on that on the next version as well. And we'll be supporting 470 gigabytes capacity currently. There's something on the IC called a vet key, and this also allows a really cool use case called for privacy. So you can potentially have this data in a private state running on a blockchain, which just kind of sounds pretty crazy. Because most blockchains are completely public and open data, but with the IC, you can potentially have something called vet keys that will allow you to have privately stored data running on the IC. For the AI.Kinic.io setup, it's set up basically in this way with the vector library in between. There's an IC WASM that actually does the rag in your browser, and it stores it in the IC stable memory. There are a few different types of vector databases. The one that we're using right now is just HNSW. It doesn't allow updates. So basically, it's a linked list, so if you upload data once, you're stuck there. But for things like updating sites on a search engine, people change their sites quite often. So we need something a little bit more nimble. And that's where the newer Vamana type indexing will come in. The library is called Vectune. It'll have an entry point where you can basically go through and update as you go. It's graph-based, K and search, library licensed under open source. And I think it's actually the first Rust version of Vamana indexing. I always mess the word up as well. So it's actually, I would say, pretty cutting edge. The first week release it, there's over 300 downloads just because people want to try Rust vector DBs. And also there's other things at Candle that are also done in Rust. So it's been good experiment in open sourcing. We can actually increase the memory load by using this newer Vectune database. Right now, it's actually quite limited, but with this, we can actually expand to more, potentially more canister smart contracts and have more memory actually be indexed at once. Now I'm going to go to demonstration where hopefully it shows end to end. Like I really hate doing stuff live because there's always like this demonstration effect. So prefer definitely recordings up front, but here we go. So we went to the UI, it doesn't actually show the UI here, and we logged in. This requires something called the internet identity, which is commonly used in the IC ecosystem to log in. With this, you can actually see your endpoint and you can name the endpoint. Our very low-hanging fruit use case was actually to get the Dfinity dev docs themselves to run on the IC. Currently, they're using like a different provider, but we really wanted to show that you can actually, in fact, do it directly from the Internet Computer blockchain, host these dev docs, and have a search engine run directly. You get a payment account. You can actually send it Kinic from a few different ways. We're actually using the NNS DApp that's online to send this canister Kinic tokens. After you send it, you have to confirm that you sent the payment. And then it turns your Kinic tokens into a canister that has Vectune running in the background. Now you need to set it up. So you actually load any JSON file. The exact rules, I think you just need like each key to be sentence or something like that. But you can use basically any form of JSON to do this. I don't know if people prefer JSON or JSON. It's whichever you prefer. This is actually the developer document that we found online, and we just turned it into a relatively large JSON file. And most of this work right now is actually being done in the browser. And after that's complete, we can actually upload it to the vector database itself. It's going to overwrite all the data from the other limitation I mentioned earlier. The next version will actually have an update button as well. And our core, like very first use case was this semantic search type model. We're actually using BERT here, and it's just a very simple example of showing what you can do. And this is also running in the browser, with the database being on the Internet Computer blockchain. So it's pretty good. You can't really ask like super deep questions to have a conversation with it, but just for the semantic type search, I think it's very, very good. It pulls relevant docs and the information that you would want to see basically with a query. And once again, from the Dfinity dev docs themselves, it's pulling up answers about the Bitcoin integration with Dfinity's ICP or the ICP ecosystem, which has a direct integration with Bitcoin via something called zkBTC, which is maybe you can see in a different talk. Hopefully I'm still on. I'm not just talking to myself. Next step for us, we are going to market for usage. There's a few Web3 companies that are actually trying it out right now as an alternative to their standard vector databases for things that need tamper-proof database. One of them is actually the company that Dfinity is currently using for the dev docs, but there's a few others as well. So there's this B2B option, but we also think there's a B2C, because potentially when models become smaller, you can run things locally, and then you can have this trustless database running somewhere else. And if you move devices, whatnot, maybe use a different phone or a different computer, you still have the data store running with your local model. So there's a few use cases we like for this, like maybe AI trading bots, personal search. Maybe you can train your own AI and then have your specific data that you don't want other people to know, and just run that all locally.
Wyatt, just to intrude for a bit, I think that your screen is not properly being shared. I don't know whether you shared at the very beginning.
Oh, damn, that sucks. Was it from the beginning, or is it still been off the entire time?
I think it's from the beginning. Maybe you can do a quick go through. Just so people.
Terrible. Yeah. Sorry, guys. I thought I was presenting with this on.
Yes, and feel free to do a slideshow full screen. Yes, exactly. Thank you.
Okay. So, yeah, that's not good. Well, while I was talking, we can just imagine this was also running in the background. I was actually at this page, which is showing the usage and the use case that we saw so far, which also means the video wasn't showing, which is, can you see the video?
Can see it.
Yeah, okay, cool. Well, we'll just run through this relatively quickly. This is important. This is at ai.kinic.io. And it's going to basically 2 minutes go over what I was just talking about, which was meant to be on the screen while I was talking. Feeding the UI Kinic to deploy this vector database. Now we're uploading the data that was in that JSON format I was mentioning earlier. And it's using the browser to vectorize it. And now we actually upload that data. In the future, this is where there will be an update as well. But currently, I will just delete all the data and basically write from scratch from the JSON file. And this is the very short example of it doing semantic search in your browser, looking for specific terms relevant to the IC. Cool, that was the demo. But above was actually also the link to the open source database if you did not want to use that UI that I showed earlier. You can actually use it directly. It's on GitHub now. It's called Vectune. And the first week it had a lot of downloads. I haven't actually checked recently what the download rate is, but there's a few different BTP use cases and BTC use cases that we're very excited about. And now we're building the V2 of this vector DB. They'll have a lot of cool features, including being able to update the data. And we're always experimenting with this idea of making AI smaller and looking at Candle and a few other different projects that have basically that as their goal. Because we feel that if you have a AI running in your browser with this tamper-proof database, you can do a bunch of really cool use cases. And potentially, if you have zero-knowledge proofs, you can actually verify things about those AI that you're running locally and have this full suite of basically verifiable AI. One example would be like biometric data, where you can scan your iris locally and not have to expose that to any blockchain just by showing that, hey, I ran this model correctly locally. Here's proof that I ran it correctly, which is maybe a topic a little bit outside the scope of this one. And we're connecting all these tools together in an easy to use interface. Basically, we can click to deploy certain tooling that runs completely on chain. Cool. I think not having the recording up for a while was probably quite awkward to watch.
Questions from chat, as it was appearing as if someone is typing. So it was fluent to the extent because we could get the context, but when something was missing. Yes, obviously for those of you that are watching the recording and those of you that are still here watching live, we will have all of the slides made available afterwards. So I will communicate with Wyatt and we'll have all of these ready for you within the Hacker Pack, as well as a recording from the session itself. And don't worry about anything that you might have missed. Everything will be made available to you and you will be able to follow up and then post questions in chat, which we can forward to Wyatt as well for additional help where needed. Before, if any of you have any questions, please make sure to post them in chat. In the meantime, I'll use the opportunity to once again share a bit about the idea submissions that will have to be done at the end of week 2, which is going to be end of next week. Towards the bottom of your screen, bottom left side, you will be seeing a link, which is the form that we'll love for you to fill out. It's just basically going to give us an idea of like what are you planning to build and what are you building already. Ideally, you will be building something by this point. It will also provide us with information about who you're working with and on what, so that we can then properly help you out with the building process over the next couple of weeks and connect you with the teams that you're building for, so that you can get the adequate technical support. I don't see any other questions. Wyatt, maybe some closing words from your end?
Yeah, oh, Alex is typing. Thanks, Alex. I wasn't able to see the chat until like right now. Yeah, we'll share the documents and the YouTube as well. You can actually go and try that online. It's like up and running whenever you want. The source code itself is also open source. You can just try that directly if you wanted to do that. It can be compiled into a canister, all that good stuff. But yeah, any questions, we'll obviously take out online. I'm wondering if you have. What type of data unions are we talking about?
For those of you that are watching the recording, the question is from Alex is, I'm wondering if you have any thoughts about application to data unions. Suspensefully waiting for what Alex will post in a second now. So he's saying, I'm thinking about a situation where people pull their data and allow the models to be run on their data, but not provide the full data itself.
That's super interesting. There's a cryptographic system called fully homomorphic encryption that could potentially allow this to happen. The issue with it right now is it has like super high overhead. With the IC itself, like that data would still be public unless you're using this thing called vet keys. And with vet keys, it's not homomorphic, which means like you can't like merge the data together with without decrypting it. You basically have the keys like to decrypt your own data. So that would be like, hey, I upload this data, it's encrypted. I want to use this data myself now. Let's decrypt it. So I couldn't like pool data together with other people just using this thing called vet keys. But with FHE, like what you could do is say, hey, here's a bunch of numbers. Like I have 5, you don't know what this number is, and you might have a number. And in the smart contract, you can actually do a function on these and output something, and no one would actually know what those 2 numbers are. So it's a type of data union. So it's like, I would say right now with the IC, you can do it for yourself if you have the key with something called vet keys. And I'm sure there's documents online on how to do that. But there is also something called FHE, which if you want to experiment with for this would be extremely cool, because if you had FHE, which is once again fully homomorphic encryption, you could do that type of data union. So you would basically encrypt the data locally, post it, and in this canister smart contract, basically have functions that work with this underlying data that no one will actually know. It won't ever be exposed to any individual, which would be a pretty cool use case for a hackathon, I would say. Once then, there's like overhead to doing FHE. Yeah, thanks for the question.
Yes, thank you. Thank you, Alex, for the questions again. Great. So I think that is it for today, everyone. Thank you all for being around. As I said, the link that I shared above, I can share once again if you want to explore the bounties that you can end up building for. Just give me a quick second. You will be able to find them here. It's basically a list of all the different bounties you can engage with, including the internet computer ones. And if you have any questions, make sure to follow up with us on Discord. We have a dedicated zones for each of the sponsor and bounty providers. So post your questions, and we'll make sure to connect you with the right people. Thank you, Wyatt, for this workshop. Yeah, once you share the slides with us, we'll make them available for everyone as well. Closing words from you?
No, awesome. Thank you. That's all.
Fantastic. Thank you. Have a great day, and thank you all for being here. See you all tomorrow.